Almost everything we see is made visible by the light it reflects. Some materials, such as air, water, or window glass, allow light to pass through. Other materials, such as wood or frosted glass, allow the passage of light in diffuse directions so that we can't see the objects through them. Here, we can see light and two different materials. The first material is opaque, while the second is transparent. Most opaque materials are things like wood, stone, and people. These materials absorb light without emission and thus allow no light to enter through them. The materials become slightly warm. As you can see, when I put the light source inside of the opaque box, you cannot see it except through the holes that are there. Now that the light has been inside of the opaque box, it is now hot enough to heat the oil that is on top. This is because in opaque materials, any vibrations from light are turned into random kinetic energy. Metals are opaque as well. In metals, the outer electrons of atoms are not bound to any particular atom. When light shines on metal, it sets these free electrons into vibration. When light shines on metal, it sets these free electrons into vibration. Their energy does not spring from one atom to another. It is re-emitted as visible light. This re-emitted light is seen as reflection, and that's why metals are so shiny. That's why in this case, if I were to put this here, we could see the light shine off the cup. But if I were to put the cup over the candle, the light is no longer visible. But if I put it in the other source, which is the glass bowl, you can clearly see everything through it, including the light source. For better reference, I'll use a bigger bowl so that the little candle is fully submerged in glass. Still visible. You are able to see the candle through this glass bowl because transparent materials allow light to pass through straight lines. Light passes through materials whose atoms absorb the energy and immediately re-emit them as light. Glass is transparent to all frequencies of visible light. The frequency of re-emitted light is identical to that of the light that has produced the vibration to begin with. The main difference is a slight time delay between the absorption and the re-emission. This time delay results in a lower average speed of light through a transparent material. A light wave incident upon a pane of glass sets up vibrations in the atoms. Because of the time delay between absorptions and re-emissions, the average speed of light is less than c. Infrared waves with frequencies lower than visible light vibrate not only the electrons but also the entire structure of the glass. The vibration of structure increases the internal energy of the glass and makes it warmer. Glass is transparent to visible light, but not to ultraviolet and infrared light. So, if I were to put this glass bowl on top of the stove, it will become extremely hot to touch. Electrons in glass have a natural vibration frequency in ultraviolet range. In ultraviolet light, resonance occurs as the wave builds a large vibration between the electron and the nucleus. The energy received by the atom can either be passed on to neighboring atoms by collisions or re-emitted as light. If ultraviolet light interacts with an atom that has the same natural frequency, the vibration amplitude is unusually large. When the electromagnetic wave has a lower frequency than ultraviolet, as visible light does, the electrons are forced into vibration with smaller amplitudes. The atoms hold the energy for less time, with less chance of collision with neighboring atoms. Less energy is transferred as heat. The energy of the vibrating electrons is re-emitted as transmitted lights. Electrons in glass have a natural vibration frequency in ultraviolet range. Our atmosphere is transparent to visible light and some infrared, but almost opaque to high-frequency ultraviolet waves. The ultraviolet that gets through is responsible for sunburns. Clouds are semi-transparent to ultraviolet, so you can get a sunburn even on a cloudy day. Ultraviolet also reflects from sand and water, so you can sometimes get a beach umbrella and still get burned. In conclusion, when you go outside, don't burn yourself. Light is worse than you thought.